Alright, so I've had an awesome question about lofting and how to use guide curves in Alibre. And I think this is something that I really should cover because I don't have content on it. Let's go with sketching on the XY plane and do a video that is simply all about lofting. Now, I expect people to know how to sketch at this level. If you don't know how to sketch, go back and learn how to sketch because you will get lost. So, first, let's start with a rectangle. We'll start with also some of these construction lines. We'll make sure that these construction lines are both equal and collinear. There we are. And then we'll grab a dimension. How about we make this something like 10 by 6. This is arbitrary, so units really don't matter. I'm in inches right now, but you can just as easily do this in millimeters, and scale in CAD platforms really is not easy to identify anyway, so it doesn't matter really what your units are for what we're doing here. Let's go with, say, an offset of 10 on our new plane, and then we'll sketch again. Now, in a lot of CAD platforms, it's best practice to go same number of sketch elements to same number of sketch elements, right? So we have a line, 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 line. That's 4 lines, so we need between a loft to have another 4 sketch elements. So if I want to go to a circle shape, to a square shape, I may feel more inclined to make 4 arcs, and that way we can go 4 vertexes to 4 vertexes, and it makes the loft pretty clear. So let's try it and see what happens. We're going to go horizontal, horizontal, and we'll add 1 vertical. And let's import a reference figure here with maintained association, and in that way I can add a horizontal there, and that's just so I can loft in a plane or sketch in a plane later on if I wish, right? And maybe I'll give this a dimension of 7, right? Kind of making that up as I go. Let's go with a loft and grab this next sketch, right? So if you notice when I go straight on, this line isn't quite horizontal. This line appears perfectly horizontal. This line is at a weird angle compared to this one, and this line is at its own angle. It's a little bit unpredictable. Now I can play with some settings here, but nothing seems to change. But this minimize twist is actually a really helpful function. And so if we're going to go same number of elements to same number of elements, I think guide curves are probably more useful, but this minimize twist can fix our problem. So why don't I open my sketch? I'm going to select everything, and we're going to say convert. I guess I have to select everything and deselect my reference figure. We'll right click, convert to reference figures, right? So this will be not driving the loft anymore. Let's go with a circle, and I'm going to make it just a slightly different size, and that way it's easy to visually differentiate what we've made. How about 14.1, right? Now we can see both a little bit easier. We'll deactivate the sketch. We'll do the loft. And we'll loft from here to here. And with this minimize curvature on, if I go back around to the back view, it knows what I'm on about, and things are now symmetric. So that is a huge help when trying to loft. But the question is, how do we now navigate when we have the same number of elements going to the same number of elements, and also how do we use things like guide curves? So let's delete the loft. I'm going to go into my sketch 2, and let's go here and say convert to regular figures. Then I'll take my outer circle, make sure that it's back to reference, and my imported line back to reference as well. Okay, so now I'm dealing with 4 arcs. So we're going to delete this. And if I go loft this, right, we're going to hopefully be back to the issue that we had before. That's great. Yep, so we're not really symmetric about anything. What do we do to fix this? Well, I can use guide curves to customize my loft a lot more. Let me give you an example. Delete my loft. Let's make a plane. We'll go offset from this plane. What do you think? 2.5. Yeah, let's go 3. All right, so we have 3 inches above, and we should be able to create a sketch on this plane. And because I made this in several parts instead of one circle, that allows me to import the parts of my sketch. So when I start sketching on this plane, and I go back into my 3D view, I have the freedom to say, let's project a reference figure of this with maintained association right into my sketch, and it stops right where we collide with the sketch plane. That makes it very easy to connect to. Let's go with project to sketch. There. We'll maintain association, and I can choose a new path for this thing to go down. I'll start pretty basic, and let's choose an arc that goes from point to point. We'll give this a dimension of, 14 looks pretty good, and we'll deactivate. When we deactivate, we will get an error. Not really an error, but a status box that says our sketch is not closed. But we don't want a closed sketch, we want a path, so we're going to ignore that. And we can also, if we wish, choose to not have that type of warning, right? So let's go lofting. All right, we'll go from one profile to the next. And this time I can choose a guide curve. And you can see our loft path now conforms to that guide curve. So that is one step in getting kind of a unique customized loft. That's pretty cool. Let's make another plane and make this loft even more complex. So I'll get rid of my loft. We'll go with a plane. Actually, you know what? I could probably just use the plane that already exists here. I'll activate a sketch, and I'll go even more simple to illustrate the point that I'm going to make. We'll make a maintain association, reference figure there. And let's project another thing right there. I could probably do all that in one go. Maintain, there we are. Oh, and I need to convert that to reference. Let's do a straight line, which, as you would agree, is more simple than an arc. Our sketch is not closed. I'm just going to say do not show this warning. Although that is very handy when you have a complex sketch and something didn't close right. That's really handy to be able to have that pop up. So click that do not show me box with discretion. Let's go with loft from here to here. And let's use a guide curve to import our straight line, right? So you can see we now have a straight line that we're dealing with. And this straight line thing, if I get rid of my guide curves, changes a few other parts of the sketch, right? So if you watch this line right here, when I click on a guide curve, it's changing some of the other lines. So note that that is a thing when you import a guide curve. It doesn't just change it locally. And we're going to talk about how to work around that. We also, let's say we want to add another sketch element, right? we were able to add that successfully. So we've got a curve on one side and a line on the other. Now, this is deceiving because sometimes you may have a failure in trying to add a second line when this is set to global. And if that's the case, or if you are affected by adding a line somewhere affects everything everywhere else, we can change this to local. And look how it changes the loft, right? I go back to global if you watch this line right here. And now this whole side is conforming with this curve. I change this back to local, and we have more of a straight line and a local part of this curve. That is a really great technology to help me customize my loss. And that is saying, hey, let's have our guide curves affect the whole profile versus having our guide curves affect local areas of the profile. Now, I can choose tangent, and of course tangent breaks. I honestly haven't used tangent very much when I've run Alibre, but the idea behind tangent is we are not going to exactly conform to the guide curves, but use an algorithm of best fit. Global and local have always met my needs, so I haven't had the need to try tangent, but that is the idea behind tangent if you wish to use it. Obviously, I haven't gotten it to work in this example. We also have the option to simplify surface, and I think it makes small changes, but I'm usually not very affected by using simplify surface or not, but we'll get into some of the other aspects as well, right? So that's how we use guide curves, and we can guide curves in a very fun way as well. So let's make this even more complex. I'll make a plane. I'll base it off of this geometry. We're going to say -3 and apply that. And now we're at this bottom end. And I can start a sketch here. Activate 2D sketch. And it's really nice that we get the grid so we can see exactly what our sketch plane is. I still want to project this guy with maintained association. And let's project this guy. This guy, of course, I don't want to be part of the loft. I think I need to switch it to there we go, reference. That's better. Let's do a spline, because splines are fun and totally unconstrained, right? So we can do a really crazy profile here, deactivate the sketch. So I'm telling Alibre that I, of course, want it to follow that spline. So we'll choose a loft, and we'll clear all because I want a loft from here to here and not loft from that crazy profile. We'll add a guide curve, and we'll choose my spline. And you know what, let's make this global and see what happens. So there's my global profile. You can see it's applying it to the entire loft profile. We'll add in another one, and that worked. We'll add in another one, and that worked as well. So you can, with a very, very dramatic difference in different profiles, you can see just how one profile affects another globally. And if I make this locally, you can see the difference. So hopefully that's a good visual indicator on global and local with multiple kinds of guide curves. And this is a way that we can make really great shapes with. All right, next thing, let's go through some lofting options. So I'm going to delete my loft because maybe I don't want to use guide curves for everything. Maybe I'll edit my sketch and say that I'm going to do, I'm editing a plane there. We'll just generate to last feature. Thank you, SolidWorks background downloader. Let's go with sketch 2, edit, and I'll select everything. And we'll make everything reference, and I'll make this circle regular. We'll deactivate and loft from one to another. Of course, our loft is looking pretty good. And let's go with specify tangent now. So what tangent does is it makes sure that we come straight out normal to our cross-sectional profile. So it doesn't look very normal to our cross-sectional profile, but that's because I have minimized curvature on. If I unminimize my curvature, you can see how we have this coming out more normal to the profile. But what if that's not normal enough? Then I can change my magnitude. Let's try 2. You can see it's more normal now. And 3. And eventually, of course, you get so extreme that you can possibly break the loft by trying to make something that overlaps on itself and can't be made. But this whole normal profile is really helpful to create organic curvature that might be hard to create with guide curves. We can also say specify tangent on this end, and we'll say like 3. And there we have very, very simply generated geometry. If there's anything left to cover, let's edit our loft here, and we're going to say tangent angle, right? So this changes our tangent angle a bit, right? If I add 10 degrees here, you can see how much that affects our profile. And if I go normal again, right, we're going to say back to 0. So here, of course, this curvature is tangent to the normal of the cross-sectional profile that we sketched out. So it's coming straight out of the plane. That's where it's tangent to. But I can say, I want you to be 10 degrees out, and now we're tangent to 10 degrees off of the normal of the cross-sectional plane. So our whole profile is coming with an angle of 10 degrees out of the plane. You can say 20. It's kind of fun to see how far you can go until you break something. We don't even break at 90, but I bet if we have to go back out, we'll probably break at 91. Let's see. No, 91 degrees. That's amazing. 100. Wow. So you can tell we're making a shape that we never thought that we'd probably make from this. I didn't know you could actually go past the plane like that. That is incredible. 130. Wow. So you can make all kinds of crazy shapes. I actually wasn't expecting it to work this well because I've never tried it. So, hey, even in making videos, I've learned a great deal. So you can make awesome shapes with being able to use this this command. Let's go back to 0. All right, so that's tangent angle, tangent magnitude we've covered. We've covered specify tangent, guide curves. I think we talked about minimize twist. I think we've talked about everything on this menu. So of course you're not limited to just lofting from one sketch to the other. You can do as many sketches as you want. And when you go to loft, I think some of the main culprits of errors are going to be choosing sketches in the wrong order, or creating objects that have an error in them and that they probably couldn't exist in real life, like maybe something prolapses on itself in a way that just wouldn't be able to exist. If you try to make a true Klein bottle, I'm sure you can make a Klein bottle in Alibre, but the true 4th dimensional Klein bottle that can't exist in 3 dimensions, yeah, you can't make that in here either. So, and one more thing I forgot to mention, let's just do a quick little experiment, because right now on sketch 2, our sketch profile is a circle, right? So our 4-pointed profile is imaginary or construction, and our circle is just a circle. It has no vertexes on it. So let's deactivate the sketch. A little experiment here. We're going to generate all of our other guide curve sketches, and our circle, I do need to fix this one thing. Actually, before I fix it, let's do another experiment, right? So our circle is slightly bigger than where our guide curves are meeting up. So our guide curve sketches don't actually intersect the circle. And I don't know if you can tell, right? They're not intersecting the edge of the circle because it's larger. So will it work if we loft it the way it is with our guide curves that don't actually intersect the circle? We'll find out by saying loft from, say, here to here We'll choose a guide curve. The line is our simplest one, and the whole thing breaks. So, one more experiment. Sketch 2. I'll delete this here's our diameter of 14.1. If I get rid of that, and then we'll say our circle is equal to our construction line, we'll deactivate that. So now with the circle being at the same size as the construction lines, I can move my history tree. In fact, I'll just generate the last feature. Now can I go to a circle that does intersect those guide curves, but we're not intersecting a vertex on the circle. We'll loft from here to here. We'll add a guide curve there, and it does work. Let's try our funky crazy one. That also works. So the idea is your guide curves must intersect your sketch, both sketches, at some point, but they don't have to intersect vertexes. And there we go. So we can generate still just as crazy of a feature, and we can do it with a circle, not just with 4 arcs, but the 4 arcs sure do make it easy to import sketch elements with points that stop where you import them. So hopefully that is a decent overview on lofting in Alibre CAD. We've made some pretty cool stuff. I've even discovered some functionality that I didn't know was there. If this was helpful, please subscribe, and I'll look forward to seeing you in the next one.